Good afternoon. Welcome to our run through of the day 16 notes. I first have a few announcements. I am not going to be at school Monday, Tuesday, or Wednesday. If you need to make up any work, please contact me by email, or if you're making up quiz 15 specifically, please go to the assessment center. For information about that, you can just email me. Homework 15 is due today, as I announced in class last time. I will be checking that homework at the end of your block. As you're leaving, please make sure that you have completed that. If you need to, pause the video and switch over to finishing that homework before you start the notes today. There's also a quiz next block, and that's over notes 15 and 16. All right, so at the beginning of this, we're going to review some of the properties that we talked about in day 15 notes. The first two are the most basic ones that we talked about, properties 1 and 2. The way we proved these to ourselves last time was by rewriting them as exponential equations. So this one, if we rewrite it as an exponential equation, this is saying that any number raised to the power of 0 is equal to 1. If this expression relates the two numbers the same way this expression does, then if one of them is true, then the other one is also true. We also proved the second property the same way by rewriting this as an exponential equation. And again, that's a property that we're already familiar with. So if one of them is true, then the other one is also true. The next thing we're going to review is how we used the last two properties to help us solve some equations. Now this one is an extension, or is a more general formula to this one. This one is specifically this property if you have a power of 1. So just like that, we're going to use this first log property to solve our first equation. Imagine that that is a pi with a power of 1, and if the base of the log matches the base of the input, then it's all just equal to the power on that input. Our second one is using the second log property. Check that the base of the exponential part of the equation matches the base of the log, and if that's true, then this whole expression is equal to the input of the log. Our last one requires you to know that natural logs are just logs base e, and if you know that, then this matches property 1, where all of this is just going to be equal to the exponent of the input of the log. Our next section is talking about some new properties that we're going to use today. If you are interested in seeing a proof of these properties, I have put a video on my website under the resources page under test 4 and 5 review, since that's the unit we're working on now. I'm also going to attempt to make it an annotation on this YouTube video, so if you see one pop up now, then I succeeded. But just view that video if you're curious about how these properties work and kind of the behind the scenes math. Otherwise, we're just going to talk about how to use them. Now, a couple of things to pay attention to is on the left side, we have a single log. This has a product and a quotient, but there's no addition or subtraction inside that single log. Over here on the right side is where we see two logs that are being added or subtracted. Note that there's no multiplication or division on this side. So basically, you can't do something if you have a log with two things that are added. We do not have a property for expanding that. And another thing to watch out for is that all the logs that you're combining together have the same base. So something like this, we would have to evaluate each log individually and then add their two answers together. We wouldn't be able to combine that into a single log. Okay, so trying these out, for the first 3 examples, I'm going to combine the logs together in order to evaluate them. Like I said before, we could evaluate each log independently and then add what they're equal to or subtract what they're equal to together. However, if it evaluates to be a decimal, then we don't really have a way to do this at this point without having a calculator that has a base change formula. Now, on your own personal calculator, you may be able to find that base change under the math menu. It's somewhere towards the bottom. Mine doesn't have it installed, so I can't show you what it looks like. And the calculators in class will not have it as an option, so don't rely on it for a quiz or a test. So this one is asking what power of 4 is 192? But there isn't a power of 4 that is equal to 192, so we're not able to evaluate this as it is. So instead we're going to use the log property number 2 to try and combine those two inputs and see if it's a better log that we're able to evaluate by hand. Now to do that, you want to keep the same base as the previous two, and since this has a subtraction inside, we're going to make this a division. That's equal to 64. So now this problem is asking what power of 4 is equal to 64, and that power is 3. Our second one looks a little bit more complicated because it's got both addition and subtraction, but I'm going to show you two ways that you can do this. One is just working left to right and combining two logs together as you get to them, and the second is a shortcut that allows you to combine all the logs at the same time, and that's the one I'm going to use throughout the rest of the notes. The first way is to work from left to right, combining two logs at a time. So combining the first two, they're being subtracted, so we're going to divide their inputs. And now again, working left to right, I've got two more logs. This time they're joined by addition, so we're going to combine them as multiplication. Now the shortcut way is to just use the sign on the log to determine whether its input goes on the top of the fraction or in the bottom of the fraction in the combined input. So overall it's still going to have the same log base 2. And now since the 6 is the input for a log that's positive, it's going to go on the top of the fraction. The 15 is the input for a log that's negative, so 15 is going to go on bottom. And 20 is the input for a log that's positive, so that's going to go on top. Now notice that we have the exact same expression, so it doesn't matter which method you use. Now to evaluate this, I'm just going to combine these numbers just like we did on the previous example. 120 divided by 15 is 8, and 2 to the third power is equal to 8. Finally, our last one is going to use property number 3. Now this you could do again a couple of ways. You could write this as an exponential equation, and then you can solve it using the techniques that we talked about in the last set of notes. Or you can use property number 3 to bring the 100 exponent down as a coefficient and then solve that log by hand. You definitely, in both cases, don't need to evaluate what 16 to the 100th power is. That's a lot of extra work. So to use the rule number 3, we're going to take the 100 down and then evaluate this log, which is asking what power of 4 is equal to 16. And 4 to the second power is equal to 16, so this whole problem was just equal to 200. For our next section, we're going to use those properties to expand logs. Notice that none of these logs, or at least the ones on the front side, have numbers in them. And the reason for that is, if we were to start with something like log base 4 of 64, and I was asking you to expand that, you would have to look for factors of 64 or multiples of 64 if you're going to write a quotient that would each be able to be evaluated with a log base 4. It's a pretty challenging task to do, so we're just going to practice expanding and using the properties with variables instead. So when you're doing this, you want to kind of peel back layers using those properties, starting with the outermost operation that's happening. So I noticed that the outermost thing that's happening with this input is that radical. I also noticed that we don't have a property to deal with radicals. So what we're first going to do is change that radical to a power as a fraction, and then apply property number 3 so we don't have a power acting on that input. That way we can then see if the input can be split any further or simplified any further. So there's our fraction power. And then that is after using property number 3. Now it might be tempting to follow up with property number 1 for this because you see addition in the problem, but remember we didn't have a property to deal with addition on the inside of the input. So this actually can't be expanded any further unless it was factorable, in which case we could treat it like there was 2 terms that are multiplied and split those apart. However, this is not factorable, so this is as far as we're able to go expanding this particular log. Our second one has a lot of different operations happening. We've got division, we've got a radical, which is a power of 1/2, and we've got a product here between the x and the radical. Now looking at those, the outermost operation is actually the product. If I treated the power like the outermost operation, I might accidentally apply that power to the x when it's actually not acting on the x. So first thing I'm going to do is split this apart using property number 1 to get rid of that product. Then this first log is actually done. There's nothing there to simplify any further, so I'm going to focus my attention on the second log and see if that can be expanded any more. Next, I'm going to change that radical to a fraction power like I did in the last example. Now from here, there's 2 different paths that you can take. I think the one with the least room for error would be to apply that power to both terms, the y and the z, since that's a power property. It also ensures that both the y and the z end up with the 1/2 in the end, as they should, since they're both being impacted by that. I'll show you the other way that you can do it afterwards, but I would not encourage the second method because there's more room for error. There's more things that you could forget. So we have y to the 1/2 and z to the 1/2. And now I'm going to go ahead and use the quotient property number 2, to split those apart. And finally, bringing down the individual powers in front of each of those logs. Now the second method that I was saying you could have used was to keep the 1/2 on the outside, and so the next thing you would do is use property number 3 to get rid of the 1/2. The important part here is when you go to split this y over z into the subtraction using property number 2, you have to remember that that 1/2 was acting on this entire log. And you're splitting it apart, but that doesn't mean that both parts don't still get the 1/2 distributed to them. And this is the place where I often see mistakes if you're going down this path, is forgetting that the 1/2 is attached to both parts, as it was in the previous step, and I'll sometimes just see the 1/2 on the y, which implies if we worked backwards that only the y has the square root attached to it. If you do it properly and distribute the 1/2, then you get an answer that's equivalent to what we have over here. It's just a different path to get there. Now at this point, I would encourage you to pause the video and try the next 3 examples on your own. I will annotate or link a timestamp for the place where I have the answers for the next 3 posted. That way you can check your work. Come back to this point in the video if you want to see me work through those problems in case you need any help with them. Okay, so we're going to continue to expand logs, picking apart major operations that are happening there. This one is a good one to look at. We have a product between the 81 and the radical here. We've got a quotient between the numerator and the denominator. We've got a power. And if I'm thinking about what's the outermost layer of these, what is one operation that's affecting all of these terms? And if I look at them individually, the radical is only affecting the x, Product's only affecting the numerator, but the quotient is affecting all of these terms. So that's going to be the one thing that I start with first, is separating this one log into two. Then each of these logs can be broken apart again. Over here, now the major operation that's affecting all the terms on the input is the product. So we're going to split this into an 81 and the x. Now as I look across, it looks like the only thing left to do as far as the properties go is to get rid of some powers. On the second term, we've got a power of 3 and a root 4. So we're going to combine those into a single power. That would be 3 over 4. And at the same time, I'm going to use property number 3 and bring that 3 over 4 down as a coefficient. On term number 3, we've got a power of 2, so that's also going to come down as a coefficient. And now the only thing that's left to do here is take care of this first log. Because we have a number, we can actually evaluate what that log is equal to. 3 to the power of 4 is equal to 81. So this whole log is just equal to 4. And as I look across, there's no more multiplication or division inside the logs. There's no more powers to simplify, and there's no more logs that need evaluating. So it looks like we are done. For our second one on this page, example 7, I'm going to use the shortcut that I talked about on the front side with example 2. And we're just going to work that shortcut backwards. So this is a really good way to evaluate these quickly. Instead of doing this in separate parts like we did here, where I did the quotient, the product, then the powers, I'm going to kind of combine the quotient and the product together. Now, in order to do it here, because I've got two terms underneath the radical, I'm going to go ahead and change that to a power of 1/2 and distribute it to both the x and the y. That's just kind of setting me up. And then after that, we're going to use a shortcut to separate all these in one go. Okay, so now using that shortcut that I talked about, any positive logs have terms on top, any negative logs have inputs on bottom. So working backwards, I can say that this one has a log that's positive, positive, negative, and negative. So in the next row, I'm able to split all 4 of those apart in one go. There's a positive log, oops, a positive log, negative, and negative. Now the last step for these would be to take the powers down as coefficients and then double check if there's anything that I can evaluate, like we did the 81 on this side. Alright, so that's everything. Since all of our inputs are variables, there's nothing to evaluate. And our third one here, we have a addition or subtraction inside the log. And if you look back at example 4, we had something similar happening here. It had a binomial with a power attached to it. Remember, we weren't able to split apart that binomial. So in this case, I don't want to try and cube this. I want to use the fact that it's factored already to my advantage. I'm just going to be able to remove the 3 and put it as a coefficient, but I won't be able to split the x and y apart. So the first thing I'm going to do is split apart this quotient. And the only thing left for us to do here is to move the powers out front as coefficients, since we're not able to split apart that binomial. As far as notation goes, I have one comment. Do make sure that you keep parentheses around your input if it has more than one term, because if you were to write this without parentheses, it would be impossible for me to tell that you wanted the y to be part of that log's input. This looks like log of x minus a totally different term, y. So don't write it like this. Make sure you include parentheses around it to say that that x and y are both part of the input. Our next section, we're going to combine logs together. We did that before when we were evaluating the expressions and what they were equal to. This time we're working with logs that have variables, so we're not actually going to get a single answer in the end. We're just practicing, once again, combining our logs together. Now for this section, I'm going to strictly use the shortcut, but if you would like to work left to right combining two logs at a time, you should also get the same result in the end. Now, the first thing I like to do is get the coefficients back into their position as powers, basically working in the reverse order of what we did before. I like to do this ahead of time, that way I don't forget to write down a power when I go to combine them together. All right, now we're going to combine all three of these together into a single log. Any log that was positive, that input is going to go on top. And any log that's negative, that input is going to go on bottom. And now if there is nothing for us to evaluate, then we are done. All right, trying that again with our next one, moving the coefficients into the position of being a power. Oops, it's 1/4. And then next I'm going to combine all of these together into a single log where any log that was positive has its input on top, and any log that was negative has an input on bottom. All right, now this one having numbers and also having two terms with the same root index, we do have a few more steps that we can do to simplify this or evaluate parts of it. Now down here, I first notice that I can distribute this power of 3 to both of these terms, and that's going to be helpful in the next step because I'm going to try to multiply these two since they have the exact same root index. We can combine them together. Now in order to do that, I need my y's to combine, and so I need that power to not be on the outside. So 16 cubed and y cubed. Then we're going to multiply to that the y in the other index so that those are combined. All right, so next I want to evaluate what this 16 will turn into whenever I cube it and fourth root it. Now, I like to work in the reverse order where I root something first because it makes the number smaller. So just off to the side, this is what I'm thinking. Let's root the 16 first, then cube that number, and that's the same as evaluating the cube of 16 and then fourth rooting it. So the fourth root of 2, or the fourth root of 16 is 2, and 2 cubed is 8. So this term right here is just equal to 8. And then y to the fourth, and then fourth rooted is just y. All right, so this is another good place to pause if you would like to work on the next problem alone, and then I'll put a timestamp annotation here so that you can click on that and skip ahead to the answer just to check your work. Come back to this position if you want to see me go through that whole problem. So example 11 is doing exactly the same thing. So I'm going to start the same way that I did on the last two. I'll first move any powers from, or move coefficients so that they're powers, and then combine all of our logs at the same time. This over here, I noticed that I could simplify before combining logs, because when you have a power and a power on the same term, the exponents get multiplied, and 3 times 2/3 is just 2. I also see that since this is a 3/4 and a y, we can actually split this. Oh, wait, we're trying to combine. We don't need to split this. Let's keep that together. Okay, so now I'm going to combine these 3 into a single log. Positive goes on top. The negatives will go on bottom. And again, I have a few things that I can do to kind of clean this up. I've got a fraction inside of a fraction, so eventually I'm going to want to split that and flip it. And I also need to multiply it times 10. All right, and then that fraction is the same as multiplying by the reciprocal, so that will turn into 4x squared over 30y. Our last section is over changing the base of a log. A reason we might want to change the base of a log is simply to plug it into our calculator. Changing the base does not change the value that the original log was equal to. So if it's something that we're not able to evaluate by hand, changing the base is not going to make it any easier to evaluate by hand, but it will make it so that we can plug it into our calculator. As I mentioned at the beginning, the problem with our calculators right now is that we don't have a log with a base changed operation in our calculator. In your personal ones you may, in the classroom ones they're disabled, and in my personal one I don't have that function at all because it's a much older calculator, or at least the operating system is. So I'm not able to put in any base other than the ones that are on the actual keyboard itself. This log button right here is using a log base 10 by default, and the natural log button is using a log base E. So unless those are my two bases, I can't use or I can't type in any log of other bases. So the formula goes like this. We're going to split up the original log into a quotient where the base of these logs are whatever we're able to type into our calculator. So this B would be a 10 if we want to use the log button, or we can make it E if we want to use the natural log button. That is completely up to you. They're both going to get you the same result in the calculator either way. And then the input from the original log goes on top, and the original base is the base of the fraction. It goes into the denominator. So let's see this in action. For the first one, I'm going to choose to do a log base 10. For the second one, I'll do a log base E, and then for the third one, we'll do both and compare them just to prove to you that it doesn't matter which base you go with. Here, if I want a log base 10, I'm going to make both of the logs in the quotient base 10. Then the input from the original log goes on top, and the base from the original one goes into the base of the fraction. It's in the bottom. Now we're able to type that into our calculator using the log button on the keyboard. So I'm going to hit log 59 divided by log of 3. Even though you don't see a base number there, your calculator is assuming you have a log base 10. And it gives us this long decimal that we wouldn't have been able to find by hand. Our directions say to round to the 6 decimal places. 1, 2, 3, 4, 5, 6. Okay, for our second one, we're going to do a log base E, just to show you that it's possible to do either one. The original input goes on top, and the original base goes on bottom. Now, since it's a log base E, this time around, I'll hit the natural log button on my keyboard. So natural log 3.56 divided by natural log of 16. Here's my decimal. So rounding that, it's 0.12345 5, 6. All right, and then our final one, I want to show you that it doesn't matter which base you go with. So I'm going to set this one up with both a log base 10 and also log base e. And if we did this correctly, we should get the exact same result either way. Okay, so log base 10. Whoops. 2.321928. Okay, now I should get the exact same thing whenever I do a natural log. Exactly the same number. So in the end, it doesn't matter which base you change it to, you just want to change it to something that your calculator can handle. Now at the bottom we have all of the properties that we've learned over the last 2 days of notes. These properties are not going to be given on the next quiz, including the change of base formula. So some that you'll definitely need to know is change of base formula and how to separate the product and quotient. The other ones, let's just double check. Yes, all of the other ones were the ones that you could get away with not knowing as long as you know how to change a log to an exponent and an exponent back to a log. However, they're very useful to know because they make evaluating a little bit faster. All right, so that's everything. Remember, you have homework number 16 posted online, and there will be a quiz next class. Thanks.